Alright, this is Thermodynamics II homework for South Dakota School of Mines and Technology. This is homework number 6, which is Raoult's law for adults, or vapor-liquid equilibrium, and azeotropes as a result. Okay, so we're doing number 5, which is from Koretsky 8.23. So if you're listening in at home, and you use the book Koretsky, but you're not in my class, that's okay. You can follow along just the same. Okay, and so it's saying, I know the temperature, and I know the pressure, but I don't know, everything else. And it says assume Porter model, or 2 suffix Margulis, so we won't worry about that. Those are details. I'm assuming I can also use Antoine's, again, details. But really, I need to know, okay, what do I mean by don't know? Well, I need to know what equations I'm using. So I'm using Raoult's law for adults. What do I mean by Raoult's law for adults? I mean, Raoult's law that does not assume, Raoult's law that's low to moderate pressures, but does not assume an ideal solution. So that's Raoult's law for adults, okay? But the other one I need to have is I need to have summation of xi equals 1. I also need to have the summation of yi equals 1, okay? Okay, and so, because I don't know both of them, saying what's the liquid and the vapor composition. Okay, but because I don't know because I know T, I know PI sats, but I don't know gamma i's because I don't know XI's. Okay, so I know that guy, I know that guy, I don't know that guy, I don't know that guy, and I don't know that guy, and I don't even have a value for those guys. Because again, that's where I really want to ask myself. What do I know, what do I don't know, and what do I have a value for? Okay. And so, I want to kind of approach this how I would approach every other problem, like the dew pressure, or the bubble temperature, or the dew temperature, or whatever it is. I want to approach it in the same way. Okay. I want to take the analogs from both bubble pressure and and dew pressure. I want to take the components of those and kind of combine them. And so when I had now bubble pressure, okay, I solved for yi. But with dew pressure, I did something first. Because really I have to ask myself, what do I know, what do I don't know, and what do I have a value for? Okay, these are the things I don't know. Okay, so there's a lot I don't know in this one. And I don't know more in this one than I did in the other ones. Okay, I still have enough equations and enough knowns to figure everything out, fortunately. Okay, but I still have a lot of unknowns here. Okay, so I have to ask, which one do I want to tackle? Well, I have to ask, which one is easiest to tackle? Okay, is it xi, yi, or gamma I? Well, it goes to that question, do I have a value for it? So yi could be anything from 0 to 1. Xi could be anything from 0 to 1, especially if I have multiple components. Okay, now we're assuming 2 components in this system. Now the algorithm I'm going to show on this one is only good for a 2-component system. It will not work for a 3-component system. There is a different algorithm that you can use for a 3-component system, but I'm not going to cover that algorithm. It's kind of a little bit different. I'd rather not for this class. Okay, so but when I did dew pressure, where I didn't know xi and I didn't know gamma I as a result, I did something. I assumed something. What did I assume? Initially, at least, I assumed initially that my gamma i's were equal to 1, which represented an ideal solution. So I'm assuming this is an ideal solution. It probably isn't, but let's do the math as if it were, okay? And then if we come back and use an activity model and find out gamma I is still equal to 1, well then that's good to know. But if it's not, then well, I have it set up so it's not a big deal. Okay, so I now have a value for gamma I. Now I gotta decide which one do I solve for, xi or yi. And really, in its core sense, it doesn't really matter, but it's easier to tackle xi first because xi is in gamma. Okay, And so I want the last thing I actually solve for is gamma. And the only thing I need for gamma is xi. So I want xi, in terms of having a value for it, be the last thing. Okay. So I want to solve for it first and then kind of plug things in. So I want to solve for xi. So xi is equal to yip over gamma ipi sat. Okay. As a result, and so I ask myself, okay, do I know where I have a value for yi? No. Do I know where I have a value for p? Yes. Do I know where I have a value for gamma I? I have a value for it. Do I know where I have a value for pi sat? Yes. Okay, because I know the t's. Okay. So the only thing I don't know where I have a value for is yi, but I have two of these. I have x1 equals y1p, and I have x2 equals y2p. So I still, there's too much I still don't know. But I have the summation right here that I can plug back into. And so, so I have summation of yip over gamma ipi sat is equal to 1. Okay. The thing is, though, now before, P was the unknown. When at the due pressure P was unknown, I could just pull out the P. I can't really pull out the yi because it's different for each term. Okay, and so I have to expand this out, essentially, to be y1p over gamma 1p 1 sat plus y2p over gamma 2 p2 sat. Okay. And then I use this one in a sense. I could solve for yi, but really I'm solving, because I only have two y's, it's not too bad to just solve for 1. So I have y1 plus y2 equals 1, so y2 is equal to 1 minus y1. And I can plug that into here. And so, so I'm going to have 1 over p is equal to y1 over gamma 1 p1 sat plus 1 over gamma 2 p2 sat minus y1 over gamma 2 p2 sat. Okay. And again, I can't just combine just because the numerator is common doesn't mean the denominator is common. Okay, so I can't just do a quote-unquote common denominator. I could do, so I could make this so that, okay, so I'm going to do 1 over p minus 1 over gamma 2 p2 sat. That to the minus 1 would equal gamma 1 p1 sat minus gamma 2 p2 sat all over y1. Okay. And so, moving things across, y1 is equal to gamma 1 p1 sat minus gamma 2 p2 sat times 1 over p minus 1 over gamma 2 p2 sat. Okay. Or some variation thereof. Whatever algebra you get, you're going to get something like this. Okay. But when I'm all said and done, I have to ask my 3 questions. What do I know, what do I don't know, and what do I have a value for? Do I know gamma 1? Or I have a value for it? I have a value for it. It's equal to 1. P1 sat? Yep. Gamma 2? Yep. P2 sat? Yep. P? Yep. Gamma 2? Yep. P2 sat? Yep. So I have enough to get y1. And once I have y1, I can get y2. Okay. So I have y1, I have y2, so I now have all my yi's. So what do I not have a value for? Well, if I look I have a value for no yi's. I know p. I don't have a value for or no xi. I know I have a value for gamma I, and I know I have a value for pi sat. So xi is the only thing remaining. Do I have an equation for xi? Yes, I do. And so I plug my y's into that one to get all my x's. Now, whenever I get x, I have to renormalize because x goes into, now, well, because x goes into my gamma equation. If it didn't go into gamma, I probably wouldn't need to renormalize. I think that's why I always need to renormalize it. So I need to renormalize it. How do I renormalize? Well, xi normal is equal to xi over the summation of xi's. Basically, I'm making it so that my xi's will definitely add up to 1 no matter what. Okay. And so I'm going to do that. After I get my xi's, then I'm going to renormalize. Then I'm going to renormalize. Then I'm going to renormalize. Now I have a value for xi. And so I ask myself, what do I know, what do I don't know, and what do I have a value for? Well, there's nothing I don't know anymore. I at least have a value for everything. And so I ask myself, okay, now that I have a value for everything, or know everything, what did I get a value for first? Did I get a value for yi's first? No. You may think I did, but I didn't. I got gamma I first. Okay. Now, gamma I is a function of temperature and xi. Do I know or have value for temperature? Do I know or have value for xi? I do. And so I can use these axes to get gammas. Okay. And I have gammas. Okay, well, what did I get after gamma? Well, I got y1. And what did I get after getting y1? I got y2. What did I get after getting y2? I got my xi's. What did I get after I got my xi's? I normalized. And I'm going to just keep doing this until I converge. Now, on the homework, what do I want to see? I want to see all this god-awful nonsense, and maybe a couple of values like, okay, you know, when I first calculate y1, it equals this. When I first calculate x1, it equals this. When I first calculate gamma 1, it equals this. Okay, I don't need to see every iteration, but at the very end, I want to see, okay, after 20 iterations, or how many ever it takes to converge, it eventually converges. So, you know, okay, 20 iterations, it converges, and here's the values for xi, for x1 and gamma, and y1. Okay, and that's all I need to do.